8.3 is our first section on special right triangles. There are two different types of special right triangles, and today we're just going to be focusing on the 45, 45, 90. Our objective for today is to use the relationships among the sides of special right triangles to find the missing side lengths. So in this triangle, two of the side lengths are represented with x because they are the same length, making this triangle an isosceles triangle. And then what is special about the 45, 45, 90 triangle is that the hypotenuse is always square root of 2 times as long as each leg. And that's where we get x square root of 2 from. So the two things that you're going to want to remember about this triangle is that the leg is equal to the leg, and that the hypotenuse is equal to the leg times the square root of 2. So for this lesson, this is what you're going to want to memorize for the 45, 45, 90 triangle for quizzes and tests. Sorry. So this one, you're just going to want to make sure you know it's for the 45, 45, 90 triangle. So using those equations, we can use them to find the missing side lengths of each triangle. So I know there is no variable, but I'm going to add them on here. We have x and y that we're going to be looking for the lengths of. And by looking at the angles, we know we have a 45, 45, 90 degree triangle. And looking at our two equations, we know that the leg is equal to the leg. What we're going to do is we're going to replace each of those words with what the legs are equal to. One of them is x and the other one is 6. So we know x equals 6. Now we need to figure out what the hypotenuse is. So for this one, we know the hypotenuse is equal to a leg times the square root of 2. And we're going to replace those with what they're equal to. So we know the hypotenuse, opposite of the 90 degree angle, is y. We know the legs are both equal to 6 times the square root of 2. So y is going to equal 6 square roots of 2, which is our final answer. Now let's do example B. This one, we're only looking for what the hypotenuse equals, opposite of that 90 degree angle, because they already told us that both of the legs are 4 square roots of 2. So using our equation for the hypotenuse, we're going to take the leg times the square root of 2 again. Our hypotenuse we are going to represent with x equals 4 square roots of 2 times the square root of 2. And if you want to, it is okay to type this into your calculator, or when you're multiplying two square roots together, you would get the square root of 2 times 2, and then it would be 4 times the square root of 4, which we know equals 2. So we have 4 times 2, and that will give us 8. If you were to type this into your calculator and you don't get a whole number, you will need to simplify the radicals to give an exact answer. So for these, you are always going to give an exact answer or exact numbers. All right. Using those equations again, we are going to solve for the legs. So both of the legs are represented by the same variable, x and x. We're still going to be using the equation for the hypotenuse to figure out what the legs equal. So let's start by substituting in what we know. We know the hypotenuse, opposite of the right angle, is 9 square roots of 2. The legs are equal to x times the square root of 2. Our goal for this one is to eliminate everything that's on the same side as x. So to do that, we're going to divide by the square root of 2. Those end up canceling with each other or simplifying on both sides, leaving us with x equals 9. So using this equation will help us to find the hypotenuse. We can also use it to help us find the leg length. All right, so if you want to try these last two on your own, you can go ahead and do that. And then press play once you have your answers to check your work. So in this first example down here, we are again given both of the legs. So we're looking for what the hypotenuse equals. And the hypotenuse is equal to the legs times the square root of 2. So looking at what we know, our hypotenuse is x. Our leg is 2 square roots of 2. And we're going to multiply that by the square root of 2. X equals, when you multiply two square roots together, you multiply the numbers underneath the square root sign. And remember, when you get a group of 2, you can pull it out from the square root. So we would end up with 2 times 2, which equals 4. If you didn't have that answer, make sure you change it so you have the correct work on your paper. Looking at example 2, this one we're looking for the leg lengths. We're still going to be using our equation, the hypotenuse equals leg times the square root of 2. Now we'll plug in what we know. The hypotenuse is 12 square roots of 2. The leg is x, and we're going to multiply that by the square root of 2. Solving this, we want to get x by itself. We'll divide both sides by the square root of 2, which those simplify with each other, leaving us with 12 equals x. And that's our answer. Now, somewhere on your paper, I would like you to draw one more triangle, just because we didn't go through an example like this one yet, and I want to make sure you have it on your page. So we know we have a 45 degree triangle, and both of the legs are going to be x, and this time, oh, sorry, my paper moved. This time, we're going to say that the hypotenuse is 16. So again, we are going to start this problem the same way we did with the last ones, using our equation for the hypotenuse, which is the leg times the square root of 2. Then we're going to plug in the information we know. We know the hypotenuse is 16. We know the leg is x times the square root of 2. Now you'll notice for this problem, when we get x by itself and we divide both sides by the square root of 2, on the left-hand side, we are left with 16 over the square root of 2. For a problem like this, you cannot leave your answers like that because of the square root in the denominator. So we're going to do what we call rationalizing, and we have gone over this a little bit. That's where we multiply both the top and the bottom by the square root of 2. And that will leave us with 16 square roots of 2 over 2. So whenever you multiply the same square roots together, it's just equal to the number that's underneath the square root sign. Then, once you get to this part, you are going to check with the numbers that are outside of that square root sign and see if they have any common factors. This one, they are both divisible by 2. So we're going to end up with just 8 square roots of 2 equals x. If you put it over 1, I would still count that correct, but this would be the most simplified answer. So that's just an extra example that you probably want to have down on your paper so you know how to do the problems where you do have a whole number here as the hypotenuse. If you have any other questions, just let me know.